Hi students, this is a video on solving rational equations and inequalities. Okay, we're going to solve this rational equation by clearing fractions by multiplying all terms by the least common denominator. So the least common denominator here, or least common multiple, is x minus 3. So I'm going to multiply both sides by x minus 3, and what that does is it makes my denominators cancel out. I end up with 3x equals 2x plus 3. I subtract 2x from both sides. I have x equals 3. You always want to check out your solutions, put them back into your original equation to see if, make sure that they make a true statement, and make sure that you don't have any undefined terms. So when we plug 3 back in, I get 0 in the denominator of both of my expressions on either side of the equal sign. So I know that this is not a solution, therefore there is no solution to this rational equation. Okay, so I have another one a little bit longer here. It's got 2 terms on the left side, and or 2 expressions on the left side added together, and I'm looking for my LCD. Since 2 and x minus 7 have nothing in common, my least common denominator is 2 times x minus 7. When I multiply all terms by this expression, then my denominators will cancel out. That's called clearing fractions. So I'm going to show you that in the next step. Okay, what you can see here is that in the green, I've multiplied every single term by 2 times x minus 7. So now we can go through and cross cancel. And I have 2 times 2x minus 9, which is 4x minus 18, plus my 2's cancel out. I get x squared minus 7x equals, and my x minus 7's cancel out, and I get 10. When I have a quadratic equation, I know I need to set it equal to 0. And so I have x squared, 4x minus 7x is negative 3x. Negative 18 minus 10 is minus 28 equals 0. I'm going to factor this. X minus 7 times x plus 4 equals 0. My solutions are x equals 7 and x equals negative 4. I need to check both of those. I notice right away that if I put 7 in, I make an undefined expression, so 7 is not a solution. I can check 4 in my equation. Plugging in negative 4 for x, you can see I've done the work here. I end up with a positive 17 over 11 minus 22 over 11 equals negative 5 over 11. This is true, so I know that x equals negative 4 is a solution. Okay, now we're going to solve rational inequalities. Your book teaches it slightly different way. They're both fine methods. You can use either method. I've just always taught it like this, and a little more conventional of a method. But it's really up to you. So I've written out 5 steps, and we're going to go through with an example to look at those 5 steps. And hopefully this will make sense. I'm also going to show you how to do this, how to check it with your calculator. Your book also goes through how to solve using your calculator, but I'm just going to ask you to use that method to check your answers. Okay, so I'm going to add or subtract to make the right side equal 0. So subtracting 4 from both sides, I have x minus 4 over x plus 5 minus 4 is less than 0. Then I need to add or subtract to make one fraction. Well, I need a common denominator, which is x plus 5. So I'm going to multiply this negative 4 times x plus 5 over x plus 5. And I get x minus 4 minus 4x minus 20. I have to remember to distribute that negative. All over x plus 5 is less than 0. Simplifying, I have negative 3x minus 24 is less over x plus 5 is less than 0. I need to find my critical values. Those are my zeros and my undefined, my excluded values of x. So my zeros are when the numerator is 0, right? So because I know 0 is not less than 0. So I'm going to factor my numerator, and I get negative 3x plus 8, right? Set it equal to 0, x equals negative 8. That is a critical value. The other critical value is going to be negative 5, because that's going to make this undefined. I know that's going to be a vertical asymptote. So I'm going to put these on a number line and test the intervals in between. Okay, so I have negative 8 and negative 5, my critical values on the number line. I know that when x is negative 8, I have zeros less than 0. So I know that this is negative 8 does not make this inequality true. Also, negative 5 is also not going to make it true because it's undefined. So then I'm trying to test these regions in between the two critical values and outside. So I can test negative 9, I could test negative 6, and I could test, let's just say, negative 1. So I'm going to test all of those to find out whether those values in between negative 8 and 5 make this true, or outside negative 8 and 5 make this true. Okay, I've tested negative 9. I plugged it into my original. You could plug it into either one, but I plugged it into my original inequality, and I end up with negative 13 over negative 4 is less than 4, and the question is that true? It becomes a positive 3 1/4 is less than 4. That is true. So I could go over here and just put a little plus for it being true. I could also go over and I could say, yes, all of these values less than negative 8 make this inequality true. So now I'm going to test negative 6. When I test negative 6, I end up with 10 is negative, or negative is positive, is less than 4. That is not true. So I don't want, so my region between negative 8 and negative 5 is negative. It's not true. So I could put a little negative sign there. I'm not going to put a line in between those. Okay? So then I'll test, the last I'm going to test negative 1. Okay, and I have negative 5/4 is less than 4. Well, any negative is going to be less than a positive. So this is true. And this checks. And I'm going to go up here, and I could write a little positive in this interval, and I could also draw a line that shows that any value greater than negative 5 makes this true. So now my answer, which I'm going to put in black just so it stands out here, is basically from this graph. I know that either x is less than negative 8 or x is greater than negative 5. And that is my solution region for this inequality. We're going to check this same problem now with a calculator. I'm going to show you on the next page how to check this out and see if we get the same solution. Okay, so what I did here is I actually did this on Desmos, and I plugged in, we've got two functions, x minus 4 over x plus 5, and we want to know when that function is less than 4, right? So I plugged in, we've done this before, by the way, with other chapters and other types of functions. So I graphed x minus 4 over x plus 5 and y equals 4, and I'm looking for when is this first function less than y equals 4. And as you can see, where if I look, this is where the function drops below. Let me see if I can kind of mark it here. This is where the function at negative 8 drops below, right? Drops below y equals 4. And I also know that it's undefined at negative 5 and that it's above 4 in between negative 8 and negative 5. But greater than negative 5, the function is less than 4. So I get the same, I can see the same solution here, which is x is less than negative 8, or x is greater than negative 5. So you should know how to do both. It's really helpful if you can plug this in your graphing calculator and check your solutions. All right, that's it. I look forward to seeing you on Wednesday. And we'll see you for the quiz. Email me if you have questions.